Alrighty, let's move on to problem 4. Sorry about that. It's not large enough. And this one we're dealing with an alien and its body's temperature. So we're told that the alien's body temperature varies sinusoidal with time. 15 minutes after they started timing, its temperature was at a high of 120 degrees. So the high is 120, that was at 15 minutes. So we're dealing with a maximum of when we know that occurs. So that's going to tell me it's a cosine equation. Let's see, 20 minutes later, so 20 minutes later is at a low of 104. So low is 104, and 20 minutes plus 15 is 35. It's at the low. So it's got to come down, go back up. Okay, so if it took 20 minutes to go half a period, it's going to take another 20 minutes to get back up to the maximum. So that would be at 55. So the total period is going to be 40 minutes. So E equals 40 minutes. B then is going to be 2 pi divided by 40. And if that really bothers you, since that's an integer, you can go ahead and reduce that to pi over 20. I've got to find the center point between 120 and 104, and that is 112, or the average between them if you want. So that is my sinusoidal axis, 112 degrees. To find A, it's the difference from the maximum to the sinusoidal axis or from the sinusoidal axis to the minimum, and that is 8. So my value for the amplitude is 8. And finally, C is our phase shift. Well, we're told that at 15 minutes, it's at the maximum. So I'm going to use a phase shift of 15. And I'm going to use the cosine equation. So Y equals the amplitude times cosine times my period constant, pi over 20, since I reduced it, x minus my phase shift, plus sinusoidal axis. 112. Sorry about that. That's messy looking. There is my equation, part B. Part C then asks us at what temperatures, so what we're trying to find is Y at 0. So at time 0, what was the temperature? So I'm just going to go to my calculator and put in a 0 to see what value we get. And let's come down here, and I'm going to put in 0. 117. Oops, is that right? Did I change my equation? 8 cosine pi over 20 times x minus 15. There we go. Plus 112. There we go. And we get 106 degrees. So the alien measured, or the alien's temperature is 106 degrees at time of 0. So when they started measuring it. Part D then says, what was the first moment that temperature hit 114 degrees? So somewhere over here. We know it's done this kind of thing. So this, I'm going to have to go to the calculator, and I'm going to put in 114 and find the first intersection point. So the first thing I want to do is make sure my window starts at 0, and it does. I'm going to 60. That should get through there. That looks good. Y equals, I'm putting in the 114 because that's the point I'm looking for. Let's take a look at this. So one thing I'm confirming, my y-intercept at the beginning was towards the low end, so that's good. And the first time it hits 114 degrees, it's going to be right there. So again, second trace intersect. And I'm right here. I need to put the cursor over there by moving to the left. And now we're close to that intersection point. Enter 3 times. And I get it was at 6.61. I think these are minutes, right? So 6.61 minutes is when the temperature first hit 114 degrees. Okay, last problem, number 5. And again, go ahead and try and see how much of this you can figure out before watching this. This one's a little different in that we've got a spring that is bouncing up and down. So again, let's get our 3. So this is going to be, again, the maximum height of the spring, the minimum. And let's see, we've got a stopwatch at 0.3. It reaches the high point. So the high point was 60 centimeters above the floor. And this was at 0.3. The next low point was at 40. And that was at what time? 1.8. So the difference between these two is 1.5, but that's half of a period. I need to add another 1.5 to get a full period. So that's going to occur at 3.3 seconds. It's when it's back up at the maximum. And again, we need to identify all our variables here. So A is the amplitude. Well, halfway between 60 and 40 is 50. The amplitude is the difference. So that's 10. This is 50. We know our phase shift is 0.3 because, again, we were given the phase shift for when it's at the maximum. So because we were given a time at a maximum, we want to use cosine. The period was a total of 3.0 seconds. So again, be careful whether they give you a half a period or a full period. So they gave us half a period, so we have to multiply that by 2 to get the full period. And then my period constant is 2 pi divided by that. And then we go on to our equation. So y equals 10 times the cosine of 2 pi divided by 3 times x minus my phase shift of 0.3 plus 50, the sinusoidal axis. Okay, so that is my equation, which I need to answer part B. Part B says, what is the distance from the floor when the stopwatch reads 17.2? So really what I'm trying to look for is, I'm going to call this function distance as a function of time. So the distance at 17.2 seconds, I'm just going to put that into the calculator and see what it says. Okay, and when I put in the 17.2, I get 43.31. And units there, centimeters. That's how far above the floor it is at 17.2 seconds. And obviously I didn't want to keep drawing this out to 17.2. That would take forever. So using the calculator is your best option. Part C is what was the distance from the floor when you started the stopwatch? So at time equals 0. So I know it, came back over here. I'm just not sure exactly where it was. So again, I'm just going to put a 0 into the calculator. And we get that it was at 58.1 centimeter or 0.09 centimeters. So it was close to the very top at time equals 0. Not quite at the maximum, but almost. And finally, last question is, what is the first positive value of time when it is exactly 59 centimeters? So really what I'm looking for is solving this equation. 2 pi divided by 3 times x minus 0.3 plus 0.5, or not point, that's just 50 there. Okay, now when I go to solve this, I could do a whole bunch of math to solve this, or I can just use the calculator, which is what I'm going to do. So when I go into y equals, notice I'm putting the 59 because that's the height that I want to find. For my window, I'm making sure I start at 0. And let's see this graph. So the very first time it hits is that intersection point. So I'm going to go in and find what is the value of time at that intersection point. So you can see my cursor moving very slowly. And I've got to get this all the way over to as close to, notice that it tells me where the cursor is. I'm getting as close to 0 as I can, and then telling it to find it. So at 0.85, let's round that to. So at 0.85 seconds is when it first hit 59 centimeters, or when it hit the first, that's not even the maximum, but close to the maximum. Okay, so again, the key is trying to identify all these different pieces of information so that you can build your equation. And you're going to build a cosine equation if you're given the maximum. You would build a negative cosine equation if you're given the time when it's at its minimum. So that would just have a negative out in front. And if you're given the time when it's at the center rising up, you would have a sine equation. And if you were given the time when it's at the center but heading downwards, you would use a negative sine equation. So just a negative out in front of the amplitude. Okay, good luck with these.